Open your eyes and let the world flow in. Follow me on a journey deep inside your body, to the eyes, the second most complex organ after the brain. And pay close attention, because everything you are about to see happens in the blink of an eye. Our first task is to go inside. Follow a tiny dust particle. It drifts through the air and gently lands on the cornea, the clear, dome-shaped surface at the front of your eye. Right now, you can feel it. Close your eyes, place your finger softly on your eyelid, and move your eyes left, then right. Do you feel a subtle bump? That is the cornea. The cornea has no blood vessels. It takes in oxygen directly from the air. In that sense, your eyes breathe. But it is filled with thousands of highly sensitive nerves. The moment something foreign touches it, the fastest muscles in your body react. Your eye blinks, and the dust particle is washed away. Let's try again. The only way into the eye is light. That's why we cannot see in darkness. But how do we see objects that do not produce light themselves? Light from a source, the sun, or a light bulb, strikes an object. Some of it is absorbed, the rest is reflected, and that reflected light enters your eye. It's a little dark in here. Someone turn on the light. Ah, that's better. We now race forward at the speed of light, passing through the curved cornea, which begins to focus the light, and moving toward the pupil. The pupil is not a black dot, it is an opening. Black, because there is no light inside. The red eye effect in flash photography happens when light reflects off the back of the eye, rich with blood vessels. Oh, the pupil is shrinking. The light is too bright. Tiny muscles in the iris, the colored part of your eye, relax, making the pupil smaller. This protects the eye from excessive brightness. When the light dims, those muscles contract. The pupil widens, inviting more light in. We continue inward and encounter the lens. Small, about the size of an aspirin. It grows throughout your life, much like a camera lens. Its role is to focus light precisely onto the retina, the back wall of the eye. If you are nearsighted, the light focuses in front of the retina. If you are far-sighted, the focus falls behind it. A difference so small, yet enough to blur the world. But don't worry, a simple pair of glasses can bring everything back into focus. The space inside your eye is larger than you might think. When you look in the mirror, you see only about 1/6 of your eye. The rest lies deep within your head. Your eyes are about the size of ping-pong balls, yet contain over 2 million working parts. Your eyes move thanks to 6 muscles holding them in their sockets. Up, down, left, right. When you look at a red apple on a blue table under a yellow light, the image that forms on the retina is actually upside down. But the eye is not a projector. Light merely touches neural tissue. Here are the light receptors. Cone cells allow you to perceive color. With just 3 types, red, green, and blue, you can distinguish millions of colors. And then there are rod cells. They reveal the world in black and white and allow you to see in low light and in your peripheral vision. These receptors are so sensitive that even after you close your eyes, the image lingers. They continue sending signals to your brain. Those signals travel along the optic nerve. Here lies your blind spot, an area with no rods or cones. Yet you never notice it, because the brain quietly fills in the missing pieces. At last, the signals reach the visual cortex, where the upside-down image is decoded, and the world appears just as you know it. A blue table, a red apple, a warm yellow light. We see different colors because light travels in different wavelengths. The red apple absorbs other colors and reflects red. Black objects absorb most light. White objects reflect most of it. And so, a world full of color emerges before you, all within the blink of an eye.